Differentiate each of the following with respect to x and simplify your answers wherever possible. 1 log sine x, 2 sine to the minus 1 4x, and 3x squared plus 2 over x squared plus 5. By first writing y equals tan to the minus 1x as x equals tan y, find dy dx in terms of x. Let's have a look at this then. So log sine, log of something is a function of a function, so we use the function of a function rule. So y is equal to ln sine x. So dy dx then, differentiating, dy dx log of something goes to 1 over something, multiplied by the something differentiated. Sine differentiates to cosine x. So that's cos over sine, and we need to simplify, and that's cot, isn't it? Cot x. Part 2. Sine to the minus 1 of 4x. Y equals sine to the minus 1 of 4x. It's a function of a function, sine to the minus 1 of something. So we differentiate dy dx then. Differentiating dy dx equals. Now what does sine to the minus 1 differentiate to? Let's have a look at that on the formula. Scroll down and find out what it differentiates to. Here it is here. Sine to the minus 1 of x goes to 1 over the square root of 1 minus x squared. But don't forget we're talking about sine to the minus 1 of something. So it goes to 1 over the square root of 1 minus the something squared, isn't it? Multiplied by the something differentiated, which is 4. So that equals then, let's simplify it, 4 over the square root of 1 minus 4x times 4x is 16x squared. Part 2. 3. Now we've got a rational function, polynomial of order 2 over a polynomial of order 2. So we need to do division. It's very easy to see what the division is here. So let's do that one then. So y is equal to, well, let's simplify this, 3x squared. Well, we've got x squared plus 5. So if I triple this, I get 3x squared plus 15. We've only got a 2 here, and we need a 15. So if I write 15 minus 13, I can introduce a multiple. So 3x squared plus 15 minus 13. I've still got the 2, I haven't changed it, over the x squared plus 5. Now, 3 lots of this will give these first 2 terms, so let's split it up like that then. So it will equal 3, and then we'll be left with minus 13, won't we? Over the x squared plus 5. Okay, now we can differentiate then. Probably easier to do it like this then. Dy dx is equal to, the constant goes to 0. This is something to the minus 1, isn't it? When we bring it up to ground level. So the minus will come to be with that minus to make 13 of the something to the minus 2, which we can write as underneath squared, multiplied by the something differentiated, which is 2x. So that's equal to 26x then, over the x squared plus 5 squared. So that's that one done. Okay, so that was part 3. Now part B, we need to get dy dx when y equals tan to the minus 1x. So part B, y equals tan to the minus 1 of x implies x equals tan y as is specified in the question. Differentiating, 1 is equal to tan differentiates to sec squared, doesn't it? Standard derivative, sec squared y times dy dx. So dy dx then is equal to, move the sec squared underneath the other side from times down to divide and read it from right to left, 1 over sec squared y. Now we know what tan y is, so we can replace the sec squared y by some tan squareds, can't we? If you remember that sine squared plus cosine squared, I'll just write it like this, equals 1. And then if I divide by sine all the way through, we'll divide by cos, isn't it? That's it, cos squared. That would be tan squared. This would be 1. And divide by cos squared, you'd get sec squared. So that's just a little memory jog there, the trig identity. So x squared is equal to tan squared plus 1. So this is equal to then 1 over 1 plus tan squared y. And the reason we've done that is because we know that x is equal to tan y, so we can put it in at the end. 1 over 1 plus x squared.